Hey everybody, today we're on 1.4 ratio tables. Your one objective here is that you will be able to solve problems involving ratios and rates using ratio tables. Alright, what is a ratio table? It is a table made with columns, which is what these are. Which is what these are. And filled with equivalent ratios. So, right here, up here, right, we have 1, 2, 3, 4. So we're going up by ones. Down below, we're going up by fives. So 5, 10, blank, 20. So what 5 is missing here? Correct. 15. 1 times 5 is 5. 2 times 5 is 10. 3 times 5 is 15. And 4 times 5 is 20. Over here, we have the ratio 1 to 7. So it would look like this, or 1 colon 7, okay? So in order to go from 1 to 3, we have to multiply it by 3. So whatever we multiply over here, we have to multiply on this side of the ratio table. 7 times 3 is 21, so that's correct. Down below, we have 7 times what gives us 56? Well, that's 7 times 8. So 1 times 8 would give us this answer here. So it's not x, it is 8. Then in this last one, we have a different color here. Yellow. Down below right here, oh my gosh, we have 7 times 9 equals 63. If we multiply this number by 9, we multiply this number by 9, and 1 times 9 gives us 9. Looks weird. Okay? Alright, these are just a couple examples. Alright. But before we do ratio tables, we have to talk about equivalent fractions, which also are equivalent ratios. So remember, ratios right now can be in the form of a fraction. So we have that 1/2 is equivalent to 4/8, and 7 over 9 is equivalent to 14 over 18. That is because when you simplify this, when you simplify 4 over 8, you get 1/2. And of course, 1/2 equals 1/2. Same thing here. And in order to get from 7 to 14, we have to multiply by 2. In order to get to 9 to 18, we have to multiply by 2. So when we divide by 2, we get 7 over 9. Okay, so let's create an equivalent ratio in fraction form to, let's do 5 over 6. Okay, again, we can multiply 5 and 6 by any number. We just have to multiply them by the same number. So I can multiply them by 3 and get 15 over 18. Or I could multiply them by 5. 5 times 5 gives us 25. 6 times 5 gives us 30. Okay? Alright, so now we're going to jump into ratio tables. So here's your problem. 3 students for every 1 honey bun. So we know that we have 3 students for every 1 honey bun. So we're going to start this ratio table off pretty simply. 3 students over 1 honey bun. If I have 6 students, how many honey buns would I need? Well, I went from 3 to 6. So I multiplied 3 by 2. Since I multiplied my top number by 2, I have to multiply my bottom number by 2. 1 times 2 is going to be 2. If I have 9 students, how many honey buns would I need? Well, same thing. 3 times 3 got us 9. So 1 times 3 will get us 3. What if I want 15? Or if I have 15 students, how many honey buns will I need? Well, 3 times what gives us 15? That's right, 5. So if I multiply 3 by 5, I have to multiply this 1 by 5. And 1 times 5 is 5. So we first have to look at the ratio that's given us. Could be like a large ratio that we can simplify, or it could be an already simplified ratio like 3 to 1, where we can just multiply to make more equivalent ratios by multiplying instead of dividing. Alright, Rosita can make 13 bracelets in 7 minutes. So, let's say, so this has already been set up for you. So what if she wants to make 26 bracelets? Well, how did we go from 13 to 26? We multiply it by 2. If I multiply my top number of my ratio by 2, I have to multiply my bottom number by 2, which would be 14. Let's say that I want to multiply 26 by 2, because I would need 52 bracelets. Well, we got to multiply our 14 by 2 to get 28. So ratio tables are all about patterns and creating equivalent ratios. Alright, so now we're going to create equivalent ratios in this ratio table by scaling down using division. So it says Axel can chug 66 ounces of formula in 12 minutes. So I put my formula up top, my minutes down below. He chugs 66 ounces in 12 minutes and 11 ounces in 2 minutes. So what number can I put in between here that I can then simplify down to 11? Well, okay, first let's see if we can go from 66 to 11 using division. So if I divide 66 by 6, I get 11. So if I divide that by 6, I get 11. So let's see if it's the same for the 2. If I divide 12 by 6, what do I get? I get 2, so that's accurate. So instead of dividing it by 6, let's divide 66 and 12 both by 3. They're common factors, and they will get us a number between 66 and 11. If I divide both by 3, 66 divided by 3 is going to be 33, and 12 divided by 3 is going to give me 4. Then I can divide that to equal down to 11 over 2. Alright, you're going to create your own ratio table here. When you're ready to check your answer, hit play. I'm going to read it to you and then start your work. To make 5 apple pies, you need 2 pounds of apples. How many pounds of apples do you need to make 20 pies? So your units here will be apple pies and pounds of apples. Okay? Alright, hit play when you're ready to check your work. Alright, so I've set up my ratio table here. I have pies over apples in pounds. Whenever you see the LBS, that is the symbol for pounds. Don't ask me why. We can Google it in class sometime and figure that out. But LBS means pounds. Shoot. So for 5 pies, I need 12 pounds of apples, which is a lot of apples. And the question was, how many pounds of apples do we need to make 20 pies? So that's 20 pies. That goes in the pie category. Okay. Again, so we know that 5 is a factor of 20 because 5, 10, 15, 20. So we have to figure out how much that we need per pie. So let's do that. How much we need per pie? So I'm going to divide both by 5. To get 1 pie over 4 pounds of apples. That's awesome. So instead of having 1 pie, I have 20 pies, right? So 1 times 20 is 20. So if I multiply that by 20, I have to multiply 4 by 20. 4 times 20 is going to give me 100. So in order to make 20 pies, I need 100 pounds of apples. Alright. Right now there's three ratios here in the forms of fractions. So I would like you to create equivalent ratios to each one of these ratios. Hit play when you're ready to see if your work's right. Check your work. Okay, so let's start with 16 over 42. So right now we know that they're both even, so we know that they're both divisible by 2. So to make an equivalent ratio to 16 over 42, we can scale down by dividing by the same number, which is 2. So an equivalent ratio for 16 to 42 would be 8 to 21. Over here, we have 7 over 21. or 7, 221. So, again, I'm going to scale down by using division. You could have also multiplied as well, but I just scaled down and divided by a common factor, which is 7, to get an equivalent ratio of 1 to 3. Over here, down here, we have 32 over 8. Again, we're not simplifying ratios. We're just making equivalent ratios. So I can scale down by using division. So 32 over 8, I divided by 4 to get 8 over 2. I made another equivalent ratio by dividing again by 2 to get 4 over 1. Okay? All right, so whenever you're done with this, you have a worksheet to work on. And if you finish that, then go ahead and jump in your book and start on this section, which is section 4 in chapter 1. All right, good luck, and I will see you next time in class. Bye, guys.